In this example, we will anti-differentiate the quantity 1 divided by x squared plus 4 squared. Now, the intuition looking at this is that maybe we immediately recognize an approach. And you could maybe imagine an integral of this form appearing frequently when applying a partial fraction decomposition with this repeated irreducible quadratic term. Now, in order to evaluate this, the expression x squared plus 4 in the denominator is really kind of the indication that we should use a trigonometric substitution. And the trig substitution that would apply, since it's x squared plus a squared, is going to be x equals 2 tangent theta. Then dx is going to be 2 secant squared d theta. So rewriting our integrand, we're going to have 1 over, and in the bottom the x squared, we're going to have a 4, and it's going to pull out of both terms, tangent squared theta, and then squared, and the dx becomes 2 secant squared theta d theta. Now continuing on, immediately after making the trigonometric substitution, we simplify via the Pythagorean identity. Tangent squared plus 1 is secant squared. So in the denominator, we really have 16 from the 4 squared, secant to the 4th, and this is multiplied by 2 secant squared theta d theta. So the 2 over 16 turns into a 1/8, and secant squared over secant to the 4th is going to end up being 1 over secant squared, which is, of course, cosine squared. And by this point, anti-differentiating cosine squared should be a familiar task. We rewrite it via the half angle formula. So there's going to be a 1/2 that pulls out of the integral. And cosine squared is the 1/2 multiplied by 1 plus, so the 1/2 multiplied by 1 plus cosine 2 theta. So 1/8 times 1/2 is 1/16. Anti-differentiating term by term gives us a theta plus 1/2 sine 2 theta plus c. And we can, for convenience, rewrite that sine 2 theta as being 2 sine theta cosine theta. When it comes to resubstituting and getting everything back in terms of x, that's really just a convenient way to go about it. So 1/2 times 2 sine theta cosine theta. And just so it's as clear as possible, this sine 2 theta was replaced with 2 sine theta cosine theta. And our last step is to get back in terms of the variable x. And in order to do so, we always just go back to our trigonometric substitution and draw that corresponding right triangle. So if x over 2 is equal to tangent of theta, the corresponding right triangle would put x and 2, so tangent of theta is x, and then by the Pythagorean theorem, that other side, the hypotenuse here, is going to be the square root of x squared plus 4. So let's just put everything back in terms of that variable x. So theta is arctan of x over 2. Sine of theta is going to be x over the square root of x squared plus 4. And cosine theta is going to be 2 over the square root of x squared plus 4. And this is all plus a constant c.